So this unit is all about acids, but today we are also going to briefly talk about bases. And when these chemicals were first discovered, they weren't discovered by chemists, right? They were discovered by ancient people. They were discovered by people who didn't know anything about atoms or molecules or things like that. And these chemicals were divided based off of their properties. So we can look at the properties of acids. Acids, there's a lot of discussion about where the word acid comes from. Acare was Latin for sour. And then there's also properties of bases. And if you don't want to confuse that with like base, like an army base, a lot of people use a fancier word for base, which is alkali. Alkaline means base, which means opposite of acid. That word definitely comes from Arabic, alkaline. Alkali came from a salt derivative, or some people say it also meant bitter, but some people say it came from one, came from the other, and which one came first, chicken or egg, not really sure. We just know alkaline here means opposite of acid. And the name acid means sour, and sour is definitely anything that tastes sour, right? It tastes sour because of an acid. And somebody always asks about like those sour candies. Yeah, if you look on sour candy, often one of the ingredients there is citric acid. And that acid is what they use to add to that sour flavor. Bases taste bitter, however, right? So soap tastes very bad, tastes very bitter. Garlic has a lot of alkali in it. It gets a little bit of a bitter taste for it. It also has sugar, so you get a little bit of sweet in there. It's kind of fun. Acids, bases, they react with one another. They both can burn things, right? You can get an acid burn. You can get a base burn or an alkaline burn. Both of them will harm your skin. Both of them will harm your tongue. The burn that you feel from capsaicin. Capsaicin is the pepper taste that makes peppers hot, right? That burn it is an alkali chemical. Butter also tends to associate as an alkaline kind of taste. Another property of acids, right? You may have heard talk about pH. We talk about pH. Things that are acidic have a low pH, that is a pH less than 7. Bases tend to have a pH greater than 7. And we'll talk about pH later on this week. Acids tend to, when you add a metal to it, they tend to corrode metal. Whereas bases instead tend to form oxides with metal. Tend to. All right. So both eat away at the metal, right? Both get rid of the metal, but the way acids do it is by slowly appearing to dissolve the metal, whereas bases tend to kind of make it form this light, fluffy material, which then eventually cakes and falls off. Acids always start with H. If you write their formula the correct way, you will always start an acid with the H on there. This is always in chemistry 1. When you get to organic chemistry, you'll find that there are different classes of acids, and they kind of do their acidic thing a little bit differently. But for this class, an acid starts with H. Bases are a little different. Bases like to form OH minus in water. So you can tell what a base is because it tends to form hydroxides, which is one of those polyatomic ions, in water. And acids being the exact opposite, the thing they form in water is H+1, is because they always have an H+1. So when talking about acids, in particular, we're going to spend a lot of time this unit talking about acids. There are 2 types of acids, and we're going to talk about how to name both types. There are binary acids, and there are secondary. No. There are what we call oxyacids. And they are both named very different ways. A binary acid, binary means 2. So a binary acid has H plus some negative ion. Some negative monatomic ion. So for example, if we had H, and by the way, hydrogen, remember it's in group 1, so it always has a +1, plus something like chlorine, which always has a -1, this will form a binary acid which has the formula HCl. All right. We name that by starting with hydro. Then we put the name of the element, and then we put ic at the end. And lastly, we put acid. So the hydro blank ic is always one word, and the acid is always the second word. So in this case, we put chlor in there because this is going to be hydrochloric acid. Again, we drop the ene because saying hydrochlorinic acid sounds stupid, so we're just going to leave that part out. So hydrochloric acid, apparently, I put an E on the end of that. Oops, my bad. So you could look at something like HBr, right? This is going to be, pause, hydrobromic acid. Or you can do the other way around. So if I gave you the word hydroboric acid, right, then you would know it was an H and a B. But we need to know the charge of boron. So a lot of folks look up the periodic table and they say, wait, I remember that rule. Boron is in group 13, so 13 minus 18 is -5. But boron only has 5 electrons. It can't, it's not going to gain 5 more electrons. It's not going to double the number of electrons in it. So believe it or not, I know you may not remember this, but boron likes to stop with only 6 electrons in its outer valence shell. So I always talk about boron because it's the exception to the rule. But now that I know it's a -3, all I got to do is remember the hydrogen's a +1, and when you crisscross these, aha, there's crisscross again, you're going to get H3B. A little easier to talk about something like arsenic acid. See if you can pause and figure out what it is. If you did this right, you remember, always starts with hydrogen, always every single time. Arsenic means arsenic, arsenite. Ugh. Arsenic, there we go. There's arsenic. Arsenic is in group 15, so 15 minus 18 gives me -3. So we take that -3, we'll criss, and we'll cross, and we get H3. AS. Hydroarsenic acid, H3AS. That's for binary acids. Oxyacids, guess what they have in them? That's right, it's hydrogen plus oxygen. No, plus a polyatomic ion. So to be able to do this correctly, you must have polyatomic ion list. There is a list given to you in task 2 for today. You might want to download this. You might want to save it. All right. So there's the list of polyatomic ions, and you notice the vast majority of them, cyanide's in here twice, the exception being cyanide. The vast majority of them have oxygen in them. All right. Especially the negative ones, they all have oxygen in them. And the other thing to notice is they all end in ATE or ITE. All the ones with oxygen in an ATE or ITE. So what we're going to do then is we're going to treat them as 2 different ones. So H plus polyatomic ion Excuse me. So if I had something like HNO3, when I look on that polyatomic ion list and I see that NO3 is called nitrate. Why is there only one hydrogen here? Well, let's go back and look. There's nitrate right there. Notice it's got a -1 charge. Since it's a -1, there's only one hydrogen to it. Fan-bloody-tastic. All right. So how do we name these things? Well, there are two different ones. They either end in -ate or they end in -ite. Ates, we change to ick. Ites, we change to us. And I always remember those because one time I ate too much and I got sick. And I barfed all over Larry, but he is I, because he's one of us. You're welcome for that, by the way. Then you add acid to the name. Notice these do not start with the prefix hydro. So if you're missing hydro, you know you've got a polyatomic ion in this oxyacid. So for example, the HNO3 we had above, it's nitrate. So we go nitrate, except instead of ate, we're going to write ick. So this is called nitric acid. HNO3 is nitric acid. You try it with H3P, doggone it, PO4. Pause. I look up on my polyatomic ion, and I see PO4 is phosphate. Ates become icks, and so I call this phosphic. Except this is a weird one. We don't call it phosphic. We call it phosphoric. I don't know why, but they decided that phosphic sounded stupid. So on that one, they went back to the original syllables. And by the way, we'll do the same thing with sulfate. If you look on the list, SO4 is sulfate. And so that one is called sulfuric acid. Instead of sulfic, it's sulfuric. I know it's weird. Slightly easier one, for example, would be ClO2H. ClO2. Almost forgot the most important part of an acid, which is an H. What do you think the name of that one would be? You can pause and look it up. If you got chlorous acid, you are right, because you went back here and you looked. ClO2 is chlorite. Ites become us's, and we call that chlorous acid. Oops, clicked on the wrong window there. Sorry about that. All right, so now to go backwards. To go backwards, all you have to remember is X started off as 8s. So what we're going to do is we're going to look at, for example, hypochlorous acid. There we go. So I remember that us used to be an ite, and I'm going to look for hypochlorite. So we look on the list, and hypochlorite is right here. It's a ClO with a -1 charge. So I'm going to put ClO. Since it was -1, I only need the one hydrogen. What about something like dichromic acid? Well, we need to remember, you try it out. Pause if you need to, try it out. All right, X started off as 8s, so we're going to look for dichromate. Dichromate is Cr2O7. Doggone it, I keep opening this one up. Let's get rid of that one. Cr2O7. Furthermore, it had a -2 charge, so I know I need 2 hydrogens out in the front of it. And that's how you do that. You're either going to write the name, given the formula, or the formula, given the name. And remember, the number of hydrogens came from the fact that this thing had a -2 charge on it originally. All right, but we don't write the charges because those hydrogens are positive. They're going to cancel out the negative charge on the dichromate. You try these out then.